So let's see, I'm going to run another query here. And what this is doing is it's grouping the requests by project. So again, English versus English Mobile versus French. And it's counting them. And then it's ordering them. And what this is telling us is, hey, you know, the most requests came into the English desktop project. The next one was English Mobile. Then in this particular hour, Japanese and, you know, Japanese Mobile, Spanish, etc. But I wanted to use this to just give you a tiny look under the hood for just 2 or 3 minutes as to what's kind of going on here, what might be going wrong or going right, that's really important to know about. So my claim here is that this is actually taking too long. It only took 10 seconds, but the point is that this is not working the way it's supposed to. And I don't want to get too much into the detail today, but I want to give you a glimpse of how you could explore this and some of the important tooling that's totally free with Spark for optimizing jobs. So my claim here is that we're not really getting our great cluster computing that we wanted, that we're really only using one thread, and things are not working quite right. And the way Spark runs something like this, all of the queries we're running today are running within a single application. And that application is the one that's handling the requests from my notebook. And we're running a bunch of queries, like we just ran one right there. And when you tell Spark to run a query, it breaks that query up into jobs. The jobs get subdivided into stages, and those stages get divided further into tasks. So again, in the longer course, we explore exactly how all this works because it's fairly important for getting really good performance out of Spark. In the simplest case, the real parallelism across our cluster happens at the task level. So the idea is that if I have 8 cores in my cluster, which I have here, I should be running 8 tasks at a time. And I know we haven't described exactly what a task means, but we certainly should be running 8 of something at the same time. That's the whole point of using Spark. So what I want to do is show you the Spark web UI. So even though I'm opening this up via Databricks, this web UI is 100% free and open source, and you don't need any commercial tool to get access to it. And it's essential in terms of understanding how your jobs are running. And what it allows us to do is to drill down. And I understand that I'm clicking a little bit quickly here. If this is your first time seeing Spark, I don't expect you to have any idea how I'm kind of navigating this, but I want to show you this exists. This great visual reporting tool. And what this is showing, that green line is showing the compute that's going on. And if I had lots of compute going on at once, I'd have lots of lines here in parallel, but there's only one. And what that's telling me is all of my compute is happening in a single task, which means a single thread running on a single core, and the whole rest of my cluster is being wasted. And this is obviously not what we want, right? This is, I could do this on a single machine. I don't need Spark for this. So let's go and just quickly fix this. The issue in this case is that I have one big gzip file. Gzip, just by its own design, it's not made to be split. In other words, it's not meant to be read from multiple places at once for parallel compute, kind of because gzip was invented, 20 plus years ago. Well, 30 plus now, I guess. So what I want to do is rewrite this, and I'm just going to do a really simple rewrite. I'm going to say spark.table page counts. That just finds all this page count data we've been playing with. I'm going to say .write because I want to rewrite it to some other destination. And I'm going to say .csv because I'm going to write it out as a plain text CSV just to make it super brain dead simple. And then I've got a path here which actually maps to an S3 bucket. And then what I want to do is see if I can count it from the original data, and then I'm going to count it from the new version, and you hopefully will see that the new version is actually doing 8 tasks at once. We're actually getting our parallelism back. So here is the original count. And I'll also queue up the CSV count. So we're going to get the same answer, right? The whole point of Spark is not that it gives you a different answer, it's that it does things in parallel, right? And if we look at this first job, you can see that there are 2 stages, and the first stage, which is where the reading is happening, is only one task doing all the work. Whereas in the second one, the read stage that's doing the reading and the counting has 8 tasks. And if we flip back over to the UI, we can actually see that. The stage that we're looking at is this one here. And you can see that now we're actually using all of the 8 cores in our cluster. So we're actually scaling stuff out. Now you might think, well, this is a really silly example. This is not, who would actually make a mistake like this? And the truth is, on the one hand, this is not the best example in the world, but on the other hand, I see many, many Spark deployments that are actually running slower than a single server could process the data, if you can believe that. Because if you misconfigure things, you can actually end up in that situation where you'd honestly be better off just using a single machine. Now, that's not always true, but the idea is that if we want to make sure we're doing stuff right and we're getting the most out of our IT investment in terms of people, knowledge, and physical hardware, we do kind of need to dive a little bit underneath the hood. Now I have a few notes in here kind of about what's going on and about